Let's open our journal up to the next open page. Just whatever is free on yours is perfect. So let's go ahead and write as a title, Solving Systems of Linear Equations with the calculator. So our steps. Number 1. Solve both equations for y. So sometimes they're already solved for y. If they're both already solved for y, there's nothing more you need to do. If they are not solved for y, then you need to solve them for y. Step 2. Type equations in y1 and y2. So I'm going to show you an example using the notes from yesterday. So this was one of them that we did. So we're going to type in y1 equals 2x and y2 is negative x plus 3. So everybody go to y equals. Clear out whatever is in there and put 2x into y1 and negative x plus 3 into y2. Step 3 is to graph. Click on the button that says graph. On this one, we can see our 2 lines. We can see their intersection point. So in parentheses, I'm going to say zoom out if you cannot see where they intersect. So on this one, we can see it, so we don't have to do any zooming. Zoom. And then if you click on the zoom button, then you look at the different options. So zoom in, zoom out. Another one would be zoom 6. So let's say your graph is off because you've zoomed in or out before. Zoom 6 puts it back where it should be in that regular old like 10 by 10 basically. So if I hit 6, it'll go back to normal. When we were looking for parallel and perpendicular, or really perpendicular, we went to zoom square, number 5. And that squared it up. Oh, if you hit enter before it graphs it, it pauses it. So I hit enter on accident, and now look, there's nothing there. But if I hit enter again, it's going to continue my graphing. So sometimes that enter pauses it if it hadn't finished graphing. All right, so now number 4. Second trace, which is calculate. So second trace. And I'm going to put in parentheses calculate. Calc. We're calculating where they intersect, the solution. So you should be at this screen now. Now look at our options. What are we going to click? 5. So I'm going to put number 5 is 5 intersect. We're trying to find the solution, which is also called your intersection point. Okay, now look at the graph. Once you hit 5, it comes to this graph. So look at it. And up at the top, it has y1 equals 2x. So that is the one that it's on right now. So it says first curve. So what first curve means is on your first line. We're on the first line, so that's good. Hit enter. Then it goes to the second curve. Hit enter again. Then it says guess, enter. So how many times do we hit enter? 3 times.
What was the last guess?
Yep, guess. So now it says intersection. Look, it gives us our point. Solution is whatever the x value is and the y value. So it says 1, 2. That's our solution. So it graphed it for us, and it found our solution. Pretty cool. So I'm going to look back at the notes that we did. So see how it has the same graph, and it has our intersection point, 1, 2. And we're done. Pretty cool, right? All right, so I'm going to give you another problem. We're going to do that one that had the decimal from this. So go ahead and put those into y equals so that we can see, because it wasn't an exact number, we need to see where, if 1 1/2, 2 1/2 is correct. So follow the instructions. Do y'all need this? Probably, right. All right, go to y equals, clear out what's in there on both of them. And then y1 is the first one, 3x. Oh. And really, it doesn't matter which one's y1, which one's y2. It doesn't make a difference. Okay, so you have y1, y2 in there. Okay, so now we need to follow the instructions. So it was already solved. We typed them in, y1, y2. 3 says graph. Make sure you can see where they intersect. Okay, we can see it. We don't have to do any zooming. Number 4, second trace. Number 5, and then hit enter 3 times. 1, 2, 3. 1 1/2, 2 1/2. Pretty cool, right? Okay, what about if they don't intersect? Like when they're parallel. So let's clear these. What do they have to have in order to be parallel? Same slope. So let's just make one up. Let's do 5x minus 4 and 5x plus 10. Because we know if the same slope, they're going to be parallel. So it's going to be a no solution, right? So let's see how that shows up. So hit graph. Okay, see how they're the same distance apart the whole way up? It's like railroad tracks. If we try, because we're not paying attention to what our graph looks like, let's see what it says. So second, trace, 5, enter, enter, enter. It gives you an error. So error, remember, anytime we have an error, it usually means undefined, which is also no solution. So that is how it'll show up if they are a no solution because they're parallel. Okay, the other one was whenever you had the same exact line graphed. Okay, so let's go back to y equals.
Whoa.
Bless you.
Was it you?
All right, we're going to put this in. Negative x plus 3. And let's say I didn't realize I was typing in the same exact equation. So this was on the front, the first one of that foldable. So let's say I didn't pay attention to that. I didn't realize, oh, they're the same one. It's going to be all real numbers because they're the exact same line. If I hit graph, see how it graphs right on top of the other one? Blue turns to red on mine.
It should turn into purple.
It should blend it, but it doesn't. All right, so second, trace, 5, and then hit 1, 2, 3. It just kept my y-intercept. That's not the solution because it's the exact same line, so it has to be all real numbers. Another thing you could look at is your table. Hit second graph, and look at the table. See how your y1 and y2 are the exact same numbers? All the way down. That means that it's the exact same line. All right, let's find one that we have to actually zoom out. All right, so I have one that we can use. So it's y equals negative 1/5 x plus 20. And then 5x plus 3. You should be typing those in. So let's look at what the graph looks like.
Mine says error. Oh, I didn't put
Okay, so it's graphed there, but what we know about this calculator is that this is a window. Just like if you look outside, you can only see part of the parking lot out there. You don't see the whole thing unless you get right up next to it or you go outside, right? So we have got to be able to zoom out to see the rest of this. So hit zoom, 3, and it doesn't do anything yet. This is the center of the zoom if that's where you want it to be. You can move it up, down, left, right if you want to zoom out in a certain way. I'm just going to hit enter. Now I get a blue line. I didn't have a blue line before.
Oh, you can just press a blue enter to zoom out.
I went zoom and then out, and then I pushed enter.
Okay.
So it'll just sit there with a little dot on the origin if you don't push enter. Okay, so now it's zoomed out. So now I can do second trace, 5, and then enter, enter, enter.
So would you just round the numbers?
Yeah, you would round. So it would depend on what your question asks. If it says round to the nearest tenth or round to the nearest whole number, that's how you would round. You just have to pay attention to what it asks for. So did y'all get the same intersection point as me? Okay. So that's how you would do. Now, if I want to go back to my original, so let's say I put in a new equation. I'm going to change this. Oops, I meant to put plus 2 and not plus 20. So I'm going to delete that. Let's just pretend, hit graph. It's still zoomed out. So I want to get it back to my original window. So we can hit zoom and then standard, the standard window, 6. And now it goes back to the regular window that we know of. So now we can do this again. So second trace, 5, enter, enter, enter. So it looked like it was on the y-axis, but it wasn't. It's negative 0.19 and then 2. All right. So that is all I have on using the calculator to graph systems.